Okay, welcome back. Happy Monday. We'll take our look at the calendar. Today is lesson number 22. We're going to talk about graphing parabolas. Notice this is day 1 of graphing parabolas. Right after quest number 4, we are going to have our second day on graphing parabolas. Coming up on the next 2 classes, that's Wednesday, Friday this week, we've got quadratic formula twice and a little bit on the complex numbers. So we're in the midst of doing lots of things with quadratic equations and their graphs. That's parabolas. Coming up, quest number 4, that's November 22nd, which is Wednesday, a week from this Wednesday. That's our 4th quest. I want to point out at this early moment, that is the day before Thanksgiving. It is a school day. We have classes on that Wednesday. If you absolutely cannot be here for family reasons on that day, you need to let me know ASAP. Not showing up for the quest gives you a 0 on the quest unless we have made arrangements beforehand. So don't come to me after Thanksgiving. Oh, Ian, can I make up the quest? The answer is going to be no. Okay. So if you I want you to be here that Wednesday. We're here. It's an official day. But if you cannot be, see me ASAP. Any questions on the calendar? Okay, so let's jump in here on page 177. We're going to skip around a little bit here and just do some of the highlights for graphing parabolas. But in this lesson, we learn how to graph quadratic equations. Let's move to the next page, and we will take a look at 3 graphs. The 3 graphs here are given, are the graphs of the equations that are written up above. We're not going to look at the details of those 3 equations. But for the first time this semester, we are graphing things that look like y equals something with x squared, whereas every graph we've done so far this semester has been like an mx plus b kind of thing, which we know is a line. So because the equation is more complicated, it's got x squared, the graph is more complicated. They're no longer straight, they are curvy. And there are a couple of points that we're going to plot. So what we're going to be doing is we're going to be given the graph of some quadratic equation. And we are going to, we're going to be given the equation and we're going to come up with the graph. And in order to come up with the graph, we're going to come up with a few different points. So for example, this point right here, let's do this guy. What is that point right there called? Because it's on the y-axis. It's called the y-intercept. What are these 2 points here called? Because they're on the x-axis. Those are x-intercepts, right? So we've got 3 different points there. I'm going to go a different color here. Let's go black. And I'm going to say that this point right here is the highest point on that parabola. Yeah? And this point over here is the lowest point on that parabola. And the highest or lowest point, every parabola has one of those 2 things, either a highest or a lowest point. And it has a name. It is called the, anybody know the word? Starts with a V. Vertex, that's the word. So clearly we got to draw the vertex. We have to figure out where the vertex is if we're going to draw a parabola. And then one more point that we're going to talk about that's special. We'll go blue here. Again, what's the name of this guy on the y-axis? That's the y-intercept. Now I'm going to draw a line, a vertical line that goes right through our front and the vertex on this green parabola. And would you guys agree that that line is a line of symmetry for the green parabola? It's exactly the same on the left-hand side as it is on the right-hand side. Mirror images over that line, yeah? And so if the point over there, 060, is the y-intercept, well, it's got a partner on the other side of the mirror. Looks like the partner is right over here. And so we're going to try to figure out the coordinates of that partner point, the partner point to the y-intercept, okay? So let's move on to the next page. And we will do all of those steps for this equation right here. Y equals negative x squared plus 4x minus 3. Okay, so the steps that we're about to do are pretty much written out down below. We're going to do the work, so we're not going to read the stuff that's down below. But I've written the highlights over here on the sideboard. 5 steps that we're going to go through, and you're going to do exactly these same 5 steps in the activity today. So let's start with the first thing. Does the parabola open up or down, and why? So it turns out that whether a parabola opens up or down is completely determined by the sign of the number touching the x squared. The sign of the number touching the x squared. Our standard quadratic equation is y equals ax squared plus bx plus c, where a is the number touching x squared, and b is the number touching the x, and c is the number that's by itself with no x's. Let's just identify the 3 values here. How much is a, which is the number touching x squared? It's -1. It's invisible, right? There's a negative sign. We know there's an implied 1. B is the number touching x. What is it? That's +4. And C is the number not touching any x. What is that? -3. And again, we got to make sure we grab that negative when we figure out the value of C. Okay, so I'll say again, whether the parabola opens up or down is completely determined by the sign of A. Is the sign of A positive or negative? It's negative, right? Okay, if you have a parabola that opens up, everybody look over here, looks like a smiley face, right? People that are smiling are typically positive, yes? Okay, if you have a parabola opening down that looks like a frowny face, people that are frowning are typically what? Negative. A is -1. What kind of a parabola is this? A smiley face or a frowny face? -1. Negative people frowning, right? So this guy opens downwards, and so we just have to write a little bit of justification. We say A is -1. It is less than 0. I mean, you could just write it's negative, but it's shorter to write it is less than 0, or it's bigger than 0 if it's positive. So the parabola opens down, okay? That's a full credit answer. Okay, next up, moving on to number 2 on the sideboard there, is to find the y-intercept. We know that every point on the y-axis has an x equal to 0, right? For example, this is the point 0, 8. This is the point 0, -2. Yeah? So wherever this parabola hits the y-axis, the x has to be 0. So to figure out where it hits, we're going to make the x equal 0. Let's do that here. X equals 0. So we've got our highlighted equation right up there. -0 squared plus 4 times 0 minus 3. That is substituting 0 for x. And all of those zeros don't contribute anything, so how much is the final outcome? -3, right? Lots of zeros. The -3 is the only thing left. Now this is a point, a full-fledged point with 2 numbers. We just figured out that the y was -3. Let's put that. But how much is the x? 0. It's the very first thing we did in this process, right? We let x equal 0. So on a test or a quiz, I'm going to ask you for both coordinates. Don't just tell me -3. Tell me 0, -3. You can also see that's written up here on the sideboard. 0, whatever you figure out. Let's plot that point. 0, -3. Right there. Okay, so we've got 1 point on the parabola. Sadly, there are a lot of different parabolas that go through this point right here. For example, it could hit this point and continue down further and go up. Or maybe it hits the point on its way up. Or maybe that is the vertex, the bottom point. It's actually none of those parabolas because all those parabolas open which way? Positively up, which is not what ours does. So there's, you know, the same kind of things going like downward or going upward, or maybe it is the vertex, right? So we got to figure out which one of those it is. We need more information. Next up, number 3, the x-intercepts. If the parabola hits there or the parabola hits there, I know that for each of those points, how much is the y? The y is 0, right? At every point on the x-axis. So the process here is not surprising, is you let y equal 0. So y equals 0. Go back to the highlighted equation. Change the y to 0 and copy everything else. 0 equals -x squared plus 4x minus 3. Okay. Up in orange, letting x equal 0, it was just arithmetic to calculate y. Yeah? With -0 squared plus 4 times 0 minus 3, it's easy. It's just arithmetic. But this problem right here, when we let y equal 0, is not arithmetic. It is algebra. And in fact, it is exactly the kind of equation you solved a bunch of times in the homework over the weekend, right? 0 equals some quadratic stuff. And so how do we do it? Well, either with the square root method or with factoring. Remember from last class, the square root method is only good if there's no x term. there was no x term in this one, I would use the square root method. I'd get the x squared by itself and then take a square root of both sides. But because there's an x, we can't use the square root method. We have to factor. So I'm going to write the factored version right here. So this is a 2x2 box that's coming out of this thing, but I'm just going to go ahead and write the answer here if I can figure it out. I think it's a 3 here and a 1 here and a plus and a plus. No. Change this to a -3. Okay, I think that's it. Okay, so I have hidden a lot of work in that step. That step is a full-fledged box method where you fill everything in the box, and then you fill everything in outside the box, and then you figure out what's in the parentheses, right? You'll do that in the activity. Okay, but now that we've got that factoring done, the next step is fairly straightforward. We said each of our factors equal to what number? 0, right? Because the product of two numbers equals 0, one of them has to be 0. So we just write that. 0 equals the first one, or 0 equals the second one. Best thing to do in this first equation is add the x. I know usually you'd move the -1 over, but in this case, adding the x gives you the answer in one shot. X is 1. Over here, add the 3, and we get 3 equals x, okay? Those are our two x-intercepts. And again, every point has 2 coordinates. So let's write them. In the first one, we figured out x was 1, but how much is y? It's 0. It's the first thing we did, right? Let y equal 0. So it's not 1, 3. It's not 3, 1. It's 1, 0 and 3, 0. Good? Go ahead and plot those 2 points. 1, 0, 3, 0. Okay, so our parabola is starting to take shape. Again, we knew it opened down, so I can draw something that hits these 3 things. It looks like it's going up through the Y-intercept, and then it hits the first x-intercept, and then it reaches some maximum up there someplace, and then comes back down, okay? But I need to know more. I need to know where it hits that maximum. Now, would you guys agree? I don't know how high that top point is right there. Like the way I've drawn it, it's like 1.5 or 2 or something. That's just a guess. But for sure, can you tell me what the x is at that highest point? Does everybody see it has to be 2? Right, the highest point has to be perfectly smack dab in the middle of my 2 x-intercepts, right? Because the vertex is where this symmetric line happens. And so the 2 x-intercepts, they have to be equidistant from that line in the middle. So we figure out the x-coordinate of the vertex by doing something to the 1 and the 3. Now I know we just went smack dab in the middle, but smack dab in the middle is not a math phrase. What did we do? What math word did we do to 1 and 3 to get the answer of 2? Starts with an A. We average them. Yes, that's a math word. The average finds us the number right smack dab in the middle. So that is how we're going to figure out where the x-coordinate of the vertex is. And so we will write it down someplace where I'll put it in here. Okay, so the x-coordinate of the vertex, this is not standard notation, it's my notation. The x-coordinate of the vertex is the average of the 2 x-intercepts. I know the answer is 2 in this case, but sometimes it's not obvious like this one is. So let's remember how to find the average of 2 numbers. Add and divide by how many numbers, yes? So in our case, we had 1 and 3. We add those, and we divide by what? 2, the number of numbers, right? 1 and 3, 2 numbers. And in fact, for all the ones we do today, they're going to have 2 x-intercepts. You're always going to be dividing by 2. That's how we'll find the number right in the middle. So in this case, 4 over 2 is 2. Of course it's 2. We knew that 2 was right in the middle of 1 and 3. But like I said, sometimes it's not obvious what the middle is. So there's the formula. Okay, so that's written right over here. Step number 4 on the side, it says to find the x coordinate, you are averaging the x-intercepts. And how are we going to find the y coordinate? Well, I know that x is 2, and I know that the equation that was highlighted at the top of the page tells me how to find the y for any particular x. So you're just going to plug the x into the original equation. We know that x is 2. We take that 2 and plug it right into this highlighted thing, right? That's the x. We will find the y. So let's do that. I'm going to squeeze this in here. The y coordinate of the vertex is. So this is just that equation at the top. It was negative x squared plus 4 times x minus 3. Do I have that right? No. Okay. And what number are we putting in the parentheses? 2. Right, it is just plugging x equals 2 in to find the y. Notice that I put parentheses here. Actually, it doesn't much matter in this case, but if that was a negative 2 without the parentheses, we'd have some problems. So just be in the habit of putting parentheses in. And in fact, this step should remind you a lot of the second step up here in orange. We let x equal 0, and how did we find the y? Well, we just copied the whole equation, but put 0 for the x's, right? Notice what are those zeros inside of? Parentheses. Every time I plug in an x, I'm putting parentheses. So that orange step right there looks an awful lot like this black step at the bottom. Okay, so we'll do the calculation here. That is a negative 4 plus 8 minus 3. All told, I think that's a 1. So we now know both coordinates of the vertex. What was the x? 2. What did the y turn out to be? 1, right? So it's a straightforward process. It seems like there's a lot of steps, but it's really just these 5 that I've written on the board. And with a little bit of practice, it becomes pretty fluid. Let's plot that point, 2, 1. Right there. If you make an arithmetic mistake in that step, let's suppose you get like 2, negative 1. You mess up on the sign somewhere. If you plot the point 2, negative 1, like that's an immediate red flag, right? You see the problem? I mean, like we know the vertex has to be up there someplace. This is no good. And so sometimes you get an easy way to catch a mistake. Like if the points do not appear to be lining up as nicely as they are for this parabola, go back, go through your 5 steps one more time, see if you can find the error. Okay, and then step number 5 is to find the symmetric point to the Y-intercepts. So let's find that point. It kind of seems only fair to find the symmetric point to the Y-intercept because look, the vertex doesn't have a partner. It's standing alone. The x-intercepts have each other as their partners. This orange guy has another orange point out here somewhere that goes hand in hand, right? But we just haven't plotted it yet. So we're just kind of filling out with symmetry the other point. So what I like to do here is draw my my vertical line going through the going through the vertex. That right there is my line of symmetry. And then you should be able to find the partner of this y-intercept going right over that line of symmetry. And I don't want you to just say, well, it's roughly over here somewhere. I'm going to ask you for the exact coordinates, both x and y. So how far do you have to go to get from the y-intercept to the line of symmetry? 2, right? Just count boxes. You have to go 2. So if you have to go 2 to get there, then you're going to go another 2 to get to the partner, right? So we'll plot the partner here in orange. 2, another 2 puts me right here. What are the coordinates of this point? 4, negative 3. It's a 4 because you went 2 and then 2 again. And it's a negative 3 because it's a copy of the y at the y-intercept. And then go ahead and connect your 5 dots. Draw a parabola. Okay, so in terms of drawing your parabolas, I'm guessing that some of you are much harsher about your ability to draw parabolas than I will ever be when I'm grading you. But there are two things that I'm going to be looking for where I will take points off if you make either of these two mistakes. Number one is to draw that. Parabolas are curvy. They are smooth. They are not like V's or upside down V's. Don't draw that, okay? Draw something curvy. And then the other thing that I will be taking off for is for people who do this. It's curvy. It looks pretty good for where it is, but what's the problem with what I've drawn? It stops. The parabola does not care about the 5 points that we drew. The parabola goes forever, left and right, and in this case, forever down as well. So don't stop. Just go all the way to the bottom or top of the grid, okay? I said there's two things I take off for, actually. As I'm thinking of it, there's a third thing. Is sometimes people will draw the, they'll connect the 5 dots just like I have here. And then they'll say, oh, Ian told me to go to the top or bottom of the grid, and they'll do this. Parabolas are not vertical at any point. They continue to go left and right forever, so just don't do that. And it's true they get steeper as you go left and right, but they are not vertical, okay? So the 5 steps are written out there on the board for you. On the very next page, they are typed out for you as well. And you are going to jump in here on the activities on this page.